Well, we're back right here in the studio, and we have with us right now Dr. Badr Al-Anzi. And Dr. Badr is the head of the Environmental Department at Kuwait University and research affiliate at MIT in Boston, United States. And Dr. Badr is well accomplished, and he also has a PhD in chemical engineering. And it's a pleasure to have you on our program, Doctor.
It's always nice to be here, and thanks for having me, and it's a pleasure to be with you.
Doctor, now tell us a little bit. You always are working on a lot of interesting and exciting and hard-working projects with a lot of research and things going on. Tell us what's your latest project that you've been working on, sir?
Well, you know the scarcity of water here in Kuwait, and Kuwait has one of the most severe arid climate in the world. And the water resources are limited to desalination, probably. So we have just probably underground water, which represent only a small fraction of our consumption. And therefore, Kuwait, like other countries, tries to replenish the water resources through desalination for potable uses. It's a very intensive energy process, and therefore costs a lot of money. And also, they treat wastewater for non-human consumption to a tertiary level, and they use it mainly for irrigation and landscaping. Now, when we do treat the seawater to produce potable water for human consumption, we produce brine, which this side product, we don't want it really, but it's produced with the process. And this brine, if I define it simply,
tell us, yeah.
It's the salt seawater. So the seawater, after extracting the fresh water for potable purposes, whether through MSF, multi-stage flash process, or reverse osmosis, the process discharges brine into the seawater. Now, the brine has a high salinity seawater, and also warmer than the ambient seawater. So what we call it scientifically, it causes thermal pollution and salinity pollution, along with some of the chemicals that are added at the beginning of the process to improve the process efficiency. They tend to end up with the brine and then discharge or disport into the seawater, deteriorating the coastal line of the seawater. And that's why we launched this with what we call a mega project, a signature project. This
Tell us more, Doctor.
Yeah, sure. The project is a collaborative project with MIT, Boston University, which is one of the top university in the world in engineering and science for the past 5 decades. And we got the generous grant from KFAS, really. I'd like
the Kuwait Foundation for the Advancement of Science.
I'd like to thank them for their continuous support.
They're always supporting
Definitely,
science.
always there for us, and they treat us always well. So I'd like to thank them. So this project's budget is about $5.5 million, and we formed 2 teams. One at MIT, headed by Jay Han. And the Kuwaiti one headed by me. We call them principal investigator. So we launched this project to address such challenges through increasing the energetic and environmental sustainability of Kuwaiti water management by developing, improving novel ideas and interfacing them optimally with the plant workflow. So this is in general. If you wanted to elaborate on any point, please let me know.
Yeah, tell us a little bit more now. What's this project? How is it going? What stage are we at?
Okay.
How is the collaboration going? Have you been there? Have they been here?
Definitely.
Give us more details, sir.
The project initially is scheduled for 3 years.
It just started?
No.
What stage are we in?
Last year.
Okay.
Yeah,
so how is it moving along the first 2 years?
It actually started 2015 and initially scheduled for 3 years. And because of the results and the findings and that we got, KFAS extended this project for 1 more year, which shows that we're moving in the right track.
Good.
It's excellent experience, not just for me, actually for our graduates. Now, if we're going to talk about the tangible benefits of this project, for example, one of them is the educational impact. We're having our graduates exploring MIT, and actually some of them are jointly supervising our master's
Great,
students.
good to hear
For
that.
example, I can give you some names.
Yes, sir.
Sumaya Al-Hamadi, she got her degree from civil engineering, and she started her master's with me. So I'm the main supervisor, and the co-supervisor is Professor Jayhan from the computer engineering and bioengineering at MIT.
Excellent.
Second, this is the first time it happened. The second student is Fahad Arbaya, main supervisor, myself, and the co-supervisor Eric Adam from the civil engineering.
Good to
and
hear.
they're progressing well, and they're doing a lot of good work, experimental and theoretically, and they're producing a lot of good results actually.
So it's good to see that exchange
yes.
and expertise from MIT, as you did say, world-renowned university that, without saying much more, people know the name. And now the outputs, what do you hope to be the outputs now, Doctor, as we're moving towards the end of this project? I mean, what do you hope the outputs will be?
Well, one of the mentions is the educational impact. And actually, I was one of the committee member for their PhD candidate, C1, and she graduated last year. I was the co-supervisor as well. Another tangible benefit is really to establish our labs, So we have one of the largest pilot plant ED, electrodialysis. This is to purify seawater using electricity, basically. It's different from MSF, where you use flashing, evaporation, condensation, or RO, which is membrane-based technologies. So we're also publishing in the top highly impacted journals. This will help Kuwait University ranking, in the future. So many really tangible benefits that we already have achieved in such a short time. Yeah.
Well, good to see that these benefits are moving on. And this project, are there any more people collaborating, sponsors who are joining in and aiding in this successful thing that you're doing?
Yeah, well, the main sponsor, as I said, KFS. Once you get the sponsorship, you have to stick with them, actually. And they've
been really helpful with
generous
a lot of people helping with projects.
Generous grant, and not only this, to believe in Kuwaiti researcher and scientist, and back him up all the time and support him and being there for him. That's really a great feeling, So KFS really sponsored this project for the whole period. And sometimes we have the panelists to judge our project from all over the world, and we've been progressing very well.
Doctor, the environment, you're of course a professor and the head of the environmental department at KU. Tell us now, environment, what's going on? I mean, we have a lot of things going on. I mean, we could spend probably the next many episodes and hours talking about that, but what's something that's very dear to you that you hope people would take better care of to preserve our environment for future generations, sir?
When you talk about environment, the components...
It's a big subject.
It's components, I put it simply.
Sure.
Components of the environment is air, water, and soil. Now, in this project, we was focusing on the water resources because we don't have any other resources. But if we talk about natural resources, underground water, and this underground water is under high stress. And it's been depleting because we use a lot of bottled water from Rothane and so on. So we're focusing on the seawater. So the seawater is under stress not just by Kuwait and all the neighboring countries, and it's almost closed. The Gulf, Arabian Gulf, and we used to get help from the Shatt al-Arab, but now because of the Turkish dam, now it's 95%. The flow is less. And unfortunately, Kuwait is at the other end from the Hormuz Strait, where we used to get help from the ocean to dilute this Gulf. Kuwait will take about 3 years for this dilution to reach Kuwait. So whatever we dispose,
it stays around.
Sticks around for about quite 3 years. Now the coastal line, the biodiverse coastal line, it's more vulnerable than the open seawater because it's shallow.
That's why it's always a little more polluted in that area.
Exactly. The tidal
when you go south, it's much cleaner.
It's open sea water.
Open sea, yeah.
Yeah, you have a lot of water. So whatever you dispose, it'll be diluted better than the coastal line. The coastal line, it's not steep. The slope is really not steep, and therefore will never hold a lot of water. So it'll be shallow. So whatever we dispose or other industries, it will definitely have an effect on that environmental effect. And this is what we're trying to do to mitigate the environmental impact caused by, whether desalination or other industries.
Yeah, this is essential to preserve things, correct?
Definitely, yeah.
And people seem to be a little careless with that, correct?
Yes, yes, yes. Sometimes we have to do it because you guys want to drink a lot of good potable water, and then we have to reduce the deficit between supply and demand, and therefore we have to use desalination to produce potable water and, unfortunately, discharge brine. So the technologies we use...
So it's give and take, right?
Yeah, but we can manage it in a better way. You know, we can, for example, dilute the brine before we discharge it. We can take the brine and make it more concentrated and produce salt and fresh water that can be used somewhere else. So we're using or actually exploring innovative technologies in this project to better handle the brine and manage it in a better way. And Kuwait will be the leading country in the GCC or in the world in this subject and brine treatment and management.
Doctor, what else do you have coming up? So this project will be coming towards the end. Tell us more. What else is coming up?
We have a follow-up project.
Yeah, tell us about that.
It's the plunging jet liquid reactor. We're going to use it as a brine dispenser. So what they are doing now, actually, they're just discharging the brine after they're simply mixing it with fresh seawater, just as a river. So we propose that we use a diffuser to disperse the brine in a better way, so it'll be mixed more efficiently, or have it like a waterfall, plunging jet. And this will actually target two problems or challenges. It'll mix it in a better way, and also it will increase the aeration and restore the dissolved oxygen into the seawater.
Okay, so good project that we're looking forward to. And Dr. Badr, as we're coming towards the end of our interview this evening, do you have any last words or comments for the audience watching Hala Kuwait tonight?
Good evening to you, to them, and I'd like to thank you for giving me the opportunity to introduce my project and share my thoughts and outputs and results with you, the audience, and your team as well.
Well, Dr. Badr, it's always a pleasure to have you on the program. We always learn a lot when you are with us, and you're always welcome to come on our program at any time. And thank you, sir, for coming. Thank you so much. We are speaking to Dr. Badr Al-Anzi, and Dr. Badr is the head of the Environmental Department at Kuwait University and a research affiliate at MIT and Boston in the United States, and also he has a PhD in chemical engineering. We'd like to thank him so much for being our valuable guest tonight.